Okay, so now that we're familiar with how to find domain from a graph, we're going to learn how to find the domain from its equation. So if we had a graph of something that looked like this, well, that's the graph of y equals x squared. The domain of this, you have to think domain is left and right. So how far left does the graph reach? Forever. How far right does the graph reach? Forever, with no holes in the middle. So the domain is all reals. So now what we're going to try to do is not use the graph, but use its equation. And there's a couple of scenarios here. Case 1 is for a polynomial function. An example would be y equals 2x squared plus x, y equals 3x to the fifth minus 3x squared minus 8x, or y equals x. Polynomial means that you only have x terms being added and subtracted. No denominators, no radicals, no fractions, and the domain here will always be all reals. So if there's no fraction, no radical, the domain is going to be all reals. Case 2, radical functions. An example would be y equals radical 2x minus 4. So now you have to think about what's not allowed with this. And if you're looking at a radical, you can't take the square root of a negative number. So what you want to say is the radicand can't be negative. So we can set that up as an inequality. It can't be negative. It can be 0. The square root of 0 is 0. And it can be positive. The square root of a positive number is a positive number. So we have to set up an inequality to say, I don't want this radicand, 2x minus 4, to be negative. So we see that? 2x minus 4 is greater than or equal to 0. That's saying it can be 0, and it has to be everything greater than that. So now we just have to solve an inequality. 2x is greater than or equal to 4. X is greater than or equal to 2. So what this says is as long as x is 2 or greater, we will get an output value. Let's watch what happens when you have something less than 2. Let's plug in 0. For x equals 0, we have y equals the square root of 2 times 0 minus 4. Y equals the square root of negative 4, which is not allowed. You cannot take the square root of a negative number. So that's just more proof to show that x has to be 2 or greater. Case 3. Is when you have a rational function. And that just simply is a fraction. So you have to again think, what is not allowed when I have a fraction? So let's say y equals x over 3x minus 9. So you have to go back to when we started simplifying fractions to determine when is a fraction undefined. A fraction is undefined when there's 0 in the denominator. Don't worry about the numerator. Numerator could be anything. As long as there's a 0 in the denominator, that will yield an undefined fraction. So that's exactly what we're going to do here. No 0 in denominator. So in this case, the domain is going to be all reals except what gives me 0 in the denominator. So I'm going to set the denominator equal to 0. oops, equals 9. And then I'm going to say x can be anything but this number. So divide by 3, x equals 3. So the domain, all reals, but x cannot be 3. Because if x were 3, I would have a 0 in the denominator. Any other number I plug in, positive, negative, fraction, decimal, I'll get a return value. And that's what domain is asking you. Domain is, what numbers can I plug in and get a return value? What numbers can I plug in and get an error message? That's what domain is asking you. When will I get an error message? In this case, when you plug in x equals 3, you'll get an error message. Case 4 is combining case 2 and case 3, and that's, we're going to have a radical and a fraction. So we're going to have y equals, let's say, 2x plus 1 over the square root of 6x minus 18. In this case, we have a radical, so it can't be negative, and we have a denominator, so the denominator can't be 0. We go back to case 2. What we did, we took the radicand and said it has to be greater than or equal to 0. If we did that here, if we said 6x minus 18 is greater than or equal to 0, that is telling us that 0 is allowed. 0 is not allowed here, because then we're going back to case 3, in which we have 0 in the denominator. So we're just going to have to exclude this greater than or equal to, and just make it greater than. Because if it were 0, I would have 0 in the denominator. If it were negative, I would have a negative in the radicand. So take your radicand, make it greater than 0. Or simply put, positive. So the denominator has to be positive in this case, because if the denominator were negative, I'd be taking the square root of a negative number. Not allowed. So let's add 18 to both sides. 6x is greater than 18. Divide by 6. X is greater than 3. So the domain here, x has to be greater than 3.